Hello, everyone. I'm Lucas. I work on UI frameworks at Facebook. Our team works on pretty much all the APIs that product teams use to put stuff on screen. And we work on iOS and Android and some of the cross-platform infrastructure for both. So today, this is all about Litho. So Litho is this framework that we open sourced this year in April. And we're using it heavily across many products in the company. So today I want to cover where we're coming from with the framework. Why did we build it in the first place? The API, why it's so cool, and how it's built under the hood. So let's start with a little bit of context. So Android is a big deal for us at Facebook. Every month, more than 1 billion people use our apps on Android. And it's a pretty nice number to share, but in practice for the engineers, this means that we have to support and do well and perform well on every version of Android that you can imagine. So for instance, is anyone here targeting gingerbread? Yeah, we have to do it. Yeah, so we have apps like Facebook Lite that targets emerging markets that has enough people using gingerbread that we have to care about this. So we also have to care about low-end phones. We also have to care about people with really flaky network connections and so on. So it makes for a big challenge to perform well across all these very different kinds of devices and different usage patterns in different countries and so on. So a good way to approach a problem like this is to focus on the use cases that are very common. And for us, and I would say that this is a very common pattern in general for mobile, is the notion of scrolling lists. So it's very hard to imagine. I mean, think about any product you built recently. There's usually something that scrolls, right? So the APIs that deal with efficient scrolling are usually the APIs that are very common surfaces in the frameworks that we use for building apps. And that's definitely the case for Android. For us, scrolling lists are everywhere. We internally call them feeds, and they are in the most prominent parts of the products that we build every day at Facebook. So today I want to talk about I'm going to give you a very hypothetical. There's a lot of overlap with what actually happened at Facebook in terms of how our products evolved and the challenges that we went through and tried to tackle. So I want to do a case study here of a hypothetical social app and give you a sense of the challenges that we hit as you grow the number of people working on it, the complexity of the keeping performance up even as you add more and more complexity to the product and so on. So let's imagine that you got tasked to implement this very cool social app that shows a simple list of posts. And yeah, you look at it and okay, this is classic case for a RecyclerView, right? So okay, you have this data set. It's probably going to be this list of data models you got from some endpoint on the server. You're going to create your adapter that connects that to the UI. And then you're going to implement the item views that are going to represent or define how each item are going to be displayed on screen. Sounds great. So as you know, RecyclerView is really good at dealing with large data sets. So the idea with RecyclerView, as you probably know, is the idea that you can display very large data sets, but only showing enough views to fill the viewport. So even if you have a very giant a logical list of posts, the actual number of views that are in memory at any given time is very small because you are not only showing views enough to fill the viewport, but you're also recycling them, hence the name RecyclerView. So cool. So you use RecyclerView, you implement your adapter, nothing fancy about it. There's a list of posts. Post is your data model. You implement create view holder, bind view holder, done. And then I've heard that all the cool engineers are using constraint layout these days. So you use constraint layout for your adapter, for your item view. And it's pretty much about a couple of text views and images and you're done. So at this point, yeah, you got something really efficient, very simple list. Yeah, you feel happy, everything is awesome. You ship the first version of that. And you want to keep performance up. So as you know, Android, and in the same vein, like pretty much any modern UI toolkit these days, performance is defined by the frame rate. So displays on each device have a certain frequency, so that defines how often the screen is going to refresh. So every 60 milliseconds, that's the kind of the pattern or the model that like we follow on most of the mobile devices these days. Every 60 milliseconds, the screen is going to refresh. So as a product engineer, it's your job to make sure that whatever you're doing in your app fits those windows. And as long as you keep up with these deadlines, your users are going to have a great experience. You're not going to see any jank or drop frames and so forth. So dropping frames is bad, and you want to avoid that. Cool. So in terms of RecyclerView, a key moment as you scroll is when a new item is going to show up on screen. And because this is when RecyclerView is going to do most of the work. So if there's no view to be recycled, it's going to inflate one, and then you're going to bind that view to a specific data model in that specific position you're trying to display, and then you're going to measure, layout, and draw. And all of that has to happen within 16 milliseconds. And I'm going to use this frame, like this picture, as like how we look at like the different aspects of your product and how as you grow in terms of complexity, how it adds pressure to keep up with these deadlines as we move along. But for your simple like initial version of the app, this looks awesome. Everything works. So your app is doing well. So now you want to support photos in each item. So it's not just text anymore. And at this point, like it sounds simple enough to just introduce a new view in your adapter and just hide and show when you bind the view to a new item. That sounds super simple. So you just add a new image view in your item view, and at bind time, you're going to hide or show. Sounds great. Like everything's still awesome, performing well. But now, like you start having new kinds of content in your list, and you need to handle that somehow. And at this point, you have to start using this feature of RecyclerView called view types. And view types is this notion that RecyclerView is going to create essentially different buckets for recycling. And every time you create or bind a new view, you're going to fetch these things from these separate buckets, and they're going to be recycled separately, and that's fine. Cool. So at this point, you have to introduce the notion of view types to your adapter. So you're already introducing some complexity to it, but it's fine. It's just a couple of view types. You're still feeling like you're got things under control, and life is still good. But now your app evolved, and you need to add even more types of content there. So it's not just about photos, it's about videos as well, and not only one photo, but a gallery of photos that can be shared in your posts. And at this point, your simple constraint layout, it's still cool, but you have to start thinking about optimizing your layouts a bit more, right? So that deadline of 60 milliseconds, layout, measure, and draw, it has to happen on time every time a view shows up on screen. So things are getting a little bit more complicated. So you have a few options here. You can start thinking about having each of these types of posts in different view types, but then you gotta have a very redundant recycling model because a lot of the content in each of these items is shared. So you would have a lot of replicated, duplicated views in memory if you do that. So you decide to go still with very simple system where you just have stubs for the different variations in each view, and you go with that. But at this point, you're already writing some custom layout to optimize your views because they're getting complex enough so that you have to think about this. So you just add a bunch of stubs. This is not going to work great in practice because at some point you're going to visit all the view types, all the variations of content, so they're all going to be memory anyway. But you can handle that with visibility, and it's still simple enough. You can manage. It's fine. And your app is getting a little bit more complex, and you're getting successful response from the users. So you want to start doing A/B tests, and you start seeing like the pain from having dynamic tweaks to the UI from XML. It's not usually a great like way to deal with dynamic UI code. And there's also performance implications. So as you do A/B tests on XML, I don't know, like if you've done it, you know what I'm talking about. And it's starting to get a little bit painful to run these experiments, because if you're running one, that's fine. But if there are like 3 people trying to run experiments overlapping with each other, then it gets a little bit more complicated. And this is all based on static like UI trees that are defined in XML. So a little bit annoying. You can still do it. The app is getting more complex. You have now rich text formatting. And in practice, you have to create these complex spannables and handle like clickable spans and all that. And where do you put this code anyway? So do you put this in like in the data pipeline so that like you can do this in background thread, or do you keep that in the binding logic, which is not great because you're gonna add pressure on the frame where the view is gonna be displayed. So you decide to go simple, you put that in the binding logic, you take a hit in the frame, but like you can still do it. You're not seeing anything horrible happening in the UI when you test your app in your high-end phone. Everything is awesome. So yeah, let's do this. Like it still can do it. Now you hit the tipping point. So users now can share other posts. So your view now is very complex. So you have basically enough views that you use for a whole screen in an item in RecyclerView. And no matter how you optimize your layout, this is still gonna be a close like deadline. And you're probably gonna miss it most of the time. So you can't like deal with that anymore by brute force optimizations by hand. So maybe you start doing some fancy stuff like pre-computing text layout and by hand for some like very common views, but that doesn't scale to all the views that you have on screen. It has to be very specific. So you start adding a lot more complexity there. So you need to do something more drastic here. Otherwise you get like now even on your high-end phone, you can see the frames being dropped like every time a new view comes on screen, and it's painful. So you decide to do something that is a very common Leclerc recommendation, which is breaking down your complex views into smaller items in the adapter level. Who here has played with that idea before? Yeah, there you go. Classic, right? And yeah, I mean, suddenly your items have like much simpler layouts, and yeah, the cost of displaying an item in the list is much smaller on the layout and measure and draw because you're dealing with smaller views on average, right? But then you start having a lot more view types, especially as you add more and more variation in content. So this means that the likelihood of a new view type showing up on screen is much higher, so you're gonna be inflating views more often. And even though RecyclerView has now prefetching supports, this is still gonna be a kind of like a best effort from the framework. So more inflations is gonna grow the number of drop frames, almost guaranteed. Not only that, your adapter now is hugely complex because you have to deal with all this index math of decomposing an item into multiple items in the adapter and managing all of that at the same time. And then also something that you rarely like look into, but like you basically lose the ability of treating the items in your list as one unit. So if you want to swipe a whole story and there are different items in the adapter, good luck with that, like, right? Or if you want to treat accessibility, like the items that are broken down into smaller units in the adapter level, and you want to treat that as one accessibility unit, good luck with that, you can't. So we basically broke accessibility by design here. So at this point, inflation is under pressure. Bind is under pressure, your text formatting and all the logic that you added like is getting really complicated. Your adapter is really complicated. You're getting fancy here. Measure and layout, yeah, it's a little less costly, but it turns out that people still add items in the broken down version. They're still too complicated and can drop frames. And drawing is still complex. So you end up with a lot of complexity that you have to manage yourself. And what I'm talking here is something that we went through at Facebook in a lot more complicated terms, but I'm pretty sure you share the pains in different parts of the spectrum of what I'm talking about here. So this is why we built Litho. Like Litho tries to attack this problem and make them not exist, pretty much. So we usually describe Litho as a declarative UI framework. I don't like using fancy words because when I say declarative, a lot of people would nod and say, yeah, totally. But like, what do you mean, right? So let me talk in more like practical terms. So the way we think about UI development in general, the classic UI toolkits, they use a very common model of mutating trees. So in practical terms, you inflate a tree. And every time something happens, the user interacts with any part of your tree, you run commands on it, like set text, hide this, and so forth. And that will bubble up to the root and cause the UI state to be refreshed. And so layout is recalculated and it's drawn again, right? So it's this model of create a tree, mutate the tree with imperative commands. And this comes from a very common tradition that we're all used to with object orientation. It's super flexible and it has a place in how we do things and it's awesome. But it does get very complex when you're dealing with a very stateful code at scale. So as your code becomes more and more complex, you have to put a lot of effort in the architecture and the kind of code you're writing from more people in the same code base. So Litho follows the React programming model. Who here is familiar with React? Cool. So React brings a more functional style way of thinking about UI. So the idea with React, the React programming model, is that given immutable props, immutable inputs, you're going to generate a UI. So instead of mutating a tree over and over, every time you need to build a UI, you just get inputs and generate the UI from scratch. And it may sound kind of unintuitive that you're creating the UI every time from scratch. It sounds very inefficient. And that's the fun of implementing these kind of frameworks, because the idea with the declarative part is that as a user, you don't care about what the state of the UI is at any given point. You're always creating it from scratch. And that's the liberating part of it, because you don't have to care about, oh, something happened. What is the state of that view? Oh, if this is something, then I do that. If not, I do this. With the React programming model is basically, give me the inputs, I generate the tree again. And as you can imagine, this is a much simpler way of understanding UI, because if you look at any specific part of your UI components, it's very easy to follow because you're always starting from scratch. You don't have to assume state anywhere, right? So it's a very nice programming model for very large systems, or a good way to scale whatever you're building in terms of complexity. So the central concept of the React programming model is this notion of a component. And component is essentially a function. So let's go back to Earth here and not talk about conceptual stuff anymore. So that's easier to follow. So in Litho, the base building block for anything you write is a component. And the way you write a component is you create a spec class. So I'm going to talk about the most common type of component. That's what you're going to be writing 19% of the time. So you create a class and you annotate it with layout spec. That's the top level structure of your component. And then you're going to implement a function called onCreateLayout. And that is the function that I mentioned before, creating the UI from scratch. This component, this is the classic component that you're going to write most of the time. One thing that I love about this code specifically is the static function there. There's no state. It's always just a function, and that's it. And that's how you're going to compose your UI as you grow and compose different elements together. We'll get there in a minute. So your title component, and that's the spec of that component. Let's say this is the classic Hello World example. So the UI that it generates is just a text saying hello Litho. And some interesting aspects of that. So you have the inputs for this text component is going to be the text size, and there's some nice convenience functions here to set like sizes from SP, like resources and so on. So the text color, it's coming from a resource in this case. And that's it. So that's your component. So the hello world thing. This will be conceptually equivalent of you creating an XML file with a text view in it, and then creating like a class that inflates that and shows on screen. So it's the equivalent of what you would do in Litho in this case. So hello world, hello Litho. But let's say you want to make this more flexible. So just rendering hello world on screen is not enough. So this is a title component. So you want this to like a way to configure like what text shows up as title. So you add a prop, and that's the input here. So you introduce an argument to this function annotated with prop, and that's it. You use it in the function, and that's like your title component. It's a component that takes one input, title, and you can use it anywhere like from then on. So at this point, you have a class annotated with some stuff from the framework. The code that you're going to use in your product is going to be the generated class that the annotation processor from Litho is going to generate for you. So in practice, this is going to create a builder for you with the props that you define. So in our case, the prop is Litho, is title. So title component spec generates a title component, and the create method and all the builder methods like here are generated for you. So in our case, it's one component with one prop, it's title, and that's the builder you get. So you can set title and stuff happens. So one thing that we added that was really cool is that you can annotate certain props as having certain resource types. Because very often, as you know, especially on XML, you're setting values, different attributes on the views from the resource system. So you can annotate, add an argument to your @prop annotation, saying that this is a resource type string. So what this will trigger is the framework is going to generate a bunch of convenience methods for you, so that whenever you want to set a title, you can set a title from a resource, or from like a resource ID, or a certain SP dimension, because this is a string and so on. So for example, if you annotate like the prop this way, you have title res, which is your way of setting title from a resource ID. And yeah, that's super convenient, and that's the kind of stuff that you would use in XML. And this is actually one of the reasons, if you've done enough views in code, like using the resource system in code in Android is really horrible, right? Because there's a lot of verbose code you'd have to write like because of that. And this is why a lot of people like really love XML, because you have a lot less verbose way of accessing different resources. So we try to kind of like have that in code here. Cool. So I talked about a simple component that takes like title as prop, but then you want to use it in like higher level components. So Litho has a layout system. It's Flexbox, which is very well known on the web, and we expose the notion of layout in terms of rows and columns. So in this case, you're creating a row, a horizontal container that is going to take 100% width of whatever parent like that ends up like enclosing this one. The height is going to be 120 dip. And it has two children, an image component, which is built in the framework, and your title component that we just defined. And as you can imagine, this is the content of an onCreateLayout function. And then you can compose and transform these things in terms of functions with immutable props over and over. And that's how you build UI with Litho, is composable functions put together to create higher order like UI. And the cool thing, as I said, is that this is always like stateless code, one direction like data flow, so you don't have to think about side effects or anything. It's always like you take props and you return the UI you want. And the layout system that backs Litho, not only Litho but ComponentKit, which is the iOS equivalent of Litho that my team also works on, and React Native is an open source project. So if you want to do like Flexbox stuff like in your projects, like whatever you're building, have a look at Yoga. Cool. So the other thing, like just going back to experiments, like now you don't have to like deal with XML and dynamic like tweaking of UIs and stuff like this. Doing experiments is super simple. So in this case, let's say you take an experiment as a prop of your component, and defining how your UI is going to look depending on the experiments is as simple as making decisions as you create the tree. So you don't have to think about dynamic UI code anymore. It's just about while you're creating the UI, you make decisions on top of that. So doing experiments, A/B tests with UI is like a lot simpler in that model. Cool. So that's like the very basics of Litho's API. There's a lot more stuff there. There's like a different kind of component for exposing existing views, and that's like, I guess is going to be a super common case if you're migrating your code to Litho. There's a whole like events API for callbacks and stuff like this, and all very functional and stateless the same way. So, but this is a lot to take. So I think this is the like enough to get the sense of like what Litho's API is about. So let's talk a little bit about like what's under the hood with Litho and how it solves the problems that I mentioned in the beginning of the talk. So let's understand like what happens, what's the lifecycle of each component in Litho. So everything starts with props. So you're gonna have inputs to a component that say is the root of your tree. So, and then the framework is gonna trigger the onCreate layout, the thing that you implement. That's the user space code that you have to write. So the result of your onCreate layout call is a layout tree. So that's essentially a layout tree in the sense that like you would have as a view tree in the traditional Android world. The framework is going to analyze this tree under the hood, calculate the bounds of everything, and generate a blueprint of what your component is going to be once it gets rendered on screen. So interesting thing here, conceptually what Litho does under the hood, and this is one of the big advantages of like declarative APIs, is that you don't care about like how things are going to be displayed on screen. You care more about what you want on screen. The framework takes care of the rest, right? So the blueprint here is essentially what we're doing here is splitting the notion of rendering from layout. So, and in fact, like the line, this horizontal line here also means that whatever is up above that line can run on any thread because your code is fully functional and immutable. You're dealing with immutable props. So your user code doesn't care what thread calls it because everything is immutable. You're dealing with functions. So, so not only we're splitting layout with rendering, but we also have ways to run this code in different threads. So that's a big advantage here. So once you have this blueprint, think of it as a list of like the components that are going to be rendered on screen and their bounds. You know exactly where everything's going to be at this point. Then you're going to do something we call mount, which is creating an actual view tree based on this blueprint. And that's when you actually have a view on screen. So it's very like, it might seem like with Litho we are recreating the view system from scratch, but in the end, everything that Litho does is splitting the notion of like layout like from views so that we can do more stuff ahead of time before things are actually displayed on screen. But in the end, they're all views and drawables as usual. So once you mount, that's when you have a view tree. So what is the consequence of that? Like how we can leverage this system of layout separate from rendering. So there are like a few really cool features. So I'm going to talk about 4 of them. First one is background layout. So the steps above that line that I mentioned before, they can happen in any thread. So if you think about Litho in a RecyclerView, we have this notion of layout range, which means that as soon as a component is about to be visible, we can start pre-computing the bounds of everything. So this means that like text layouts and all that, they're going to be computed before you even have a view on screen. And this is where most of the cost of displaying like items on screen come from. Text is like the worst. So Litho is pre-computing the bounds of your views before they are displayed on screen, essentially. So that like whenever they are visible, the cost of measuring them is going to be minimal. So going back to that frame that I described before, when you have inflate, bind, measure, layout, draw, in the Litho world, you don't have the cost of measure layout at all because you've done all the work already. So so this is already, you're already much in a much better place in terms of like frame time when things become visible on screen. Cool. So that's great. So the other thing is view flattening. So going back to the model that I've shown before, the cool thing about splitting layout and rendering is that you can pre-process how something's going to be rendered before they become views. So as you've seen in Litho code, you're dealing with rows and text and stuff. You're not dealing with views directly. So by the time you have a layout tree and you know the bounds of everything, and you have a blueprint, you can skip a lot of like elements from the view tree that are not useful for drawing. So very common case, you build a view tree and inevitably you're gonna have some nesting, and with some containers, they're only used for arranging their children in a certain position, right? They're kind of useless for drawing. So because we split layout and drawing, we can just like not use them at all. So by the time you mount, you can skip everything that doesn't have anything to do with drawing. So let's say, for example, in a Litho tree, you have row, one image, and then like another container, a column with text, two text, right? These two containers, they're pretty much useless once you have layout calculated because they've only been used for arranging their children. So because we split layout and rendering, by the time you create the blueprint, you skip those completely. And in practice, this means that not only we skip containers, but we can define very efficient ways of rendering stuff on screen. So they don't have to be views at all in the first place. So for example, that tree, let's say in a constraint layout or relative layout that you avoid all nesting, you would at least have 3 views here, like with one for the image and two text views, right? In Litho, it's basically one view that draws everything in one surface. Because like we flatten everything completely. So and we skip all the layout only containers. So and view flattening is not the holy grail of performance for rendering, for example. It does reduce a little bit of like overhead from like traversing more views. This has more to do with using drawables instead of views, so you save a lot of memory from that because views are very bloaty objects. The next one is fine-grained recycling, and this is something that like is one of my favorite features of Litho. So going back to the view types approach, so you have buckets for each type of like top-level item you have in your list, right? And this is like fine for like a couple of view types, but as you grow the number of like view types in your list, you have very redundant recycling model because there is a bunch of stuff that could be shared across all these elements. So conceptually, it would be the equivalent. I mean, you have text views everywhere. Why can't you just reuse them dynamically everywhere, right? I mean, in practice, because doing that by hand would be super complicated. I don't know if you've tried that. I've been there, and yeah, you don't want to go there. So with Litho, what happens is like as items go off screen, we deconstruct the composite like items into their smaller bits. So think about the text, the images, into their smaller pieces, and those elements are reused to compose any combination of content dynamically. So this means conceptually as if you're cross-pollinating all the image views and text views in any composite view that forms any item in the list, which is kind of cool. So that means that the cost of inflation is not gone, but it's hugely mitigated because instead of inflating items from scratch, you are cross-pollinating all these elements across any combination of content. And a complement to that feature is incremental mount. So incremental mount means that even if you have a gigantic item view, you're not gonna like mount or create the view tree for that item all in one go. You're gonna dynamically constructed as it becomes visible on screen. And that combined with fine-grained recycling, I guess the best picture, I couldn't come up with an animated version of that, but the best way to describe this, imagine every item and every combination of items in your list being deconstructed and recombined in any variation of content dynamically. And you don't have to care about any of that. So this is all sounding super fancy, but this is just like stuff happening under the hood. The code you write is just a few functions that you compose together and it just grows. So what incremental mount gives you essentially is, instead of doing what, like if you look at the traditional, a classic systrace for RecyclerView, you're gonna have these lumpy frames, which is when items become visible on screen. And that's the challenge of like implementing stuff in the traditional way of Android, right? Even if you optimize stuff, you're still gonna be close to the deadline of 16 milliseconds because there's a lot of work to be done. With incremental mount, you're gonna do a little bit of work across like all the frames, but you're gonna be doing very little work. So this means that like you can have essentially like gigantic item views in your RecyclerView, and the cost of rendering them will be like split across many frames instead of going all in one go. So the chances of you dropping a frame are very, very small. Cool. So that's like the feature. So you get a ton of performance with simpler code. So what's next for Litho? So I briefly covered some of the adapter stuff in the beginning of the talk. Adapter can get, I think it's like a pretty terrible kind of code to write as you scale your app. So we built an API for Litho that brings something that looks a lot like Litho components, but for connecting data to rendering in Litho. So you essentially write, again, functions to compose together and combine data from different sources, and it will compute in a background thread the change set for you and figure out the minimum amount of work to be done on the recycler adapter under the hood. So you don't have to write adapters anymore. And in practice, you're gonna provide a list of props, a list of like your data models. And we have this building block called Declarative section. So you just provide it like the list, and then when something changes, you provide the list again. And then you have this top level component that is essentially a RecyclerView under the hood. So every time your list of like data models change, you just provide the list again, and it will do the minimum amount of work on the adapter level. So all the notify calls is going to be the minimum amount of work. It's very similar conceptually to what the guys at Google are doing with the paging APIs. It's just that the programming model is a bit different. So the other thing that is coming, the sections is already announced. This was last week. I encourage you to have a look. The other thing that's coming is the animations API. So it's a declarative API. Again, declarative in the sense that you care about what you want and not so much about how it's going to happen. And it's fully interruptible and physics-based. So you can declare how a layout is going to transition to another by writing code like this. So in this case, you want two animations in parallel, one for the icon component, and you tag that with this ID or a key, and in the title, and the icon is going to animate scale X from a certain value to another value, and so on. And then magic happens. And if anything, while you're running this animation, layout changes again, it would just redirect things in a physics-based way. So, so pretty exciting stuff. The code is already landed. We're still polishing before like we open the gates for more adoption. But this is going to be pretty cool. Other stuff that are in the works, I think we need to do a better job like providing a better path for incremental adoption. So one thing that we're hearing a lot is that adopting Litho now is a big investment upfront. So we're trying to find ways for new adopters to incrementally convert their lists or RecyclerViews to Litho instead of having to rewrite things from day one. So there's some APIs in place, but we could do better. The other thing is Kotlin. We have very preliminary support for that. Like you can write code in Kotlin, but it will still look very Java-y. So we want to get to a point where your layout code is essentially a DSL in Kotlin. So you don't have builders. It's just like a very native looking idiomatic Kotlin for layout code. And we could go beyond that and like skip some code generation and just leverage some of the Kotlin language features instead of what we're doing now. So one thing that is going to be challenging for us for Kotlin, I think is like worth calling out, is that like we don't use Kotlin at Facebook, at least for the main products. There is some use of Kotlin right now. So any help from the community is going to be super appreciated in terms of feedback, ideas on how the API could feel more Kotlin-y, and so on. So definitely like welcome feedback here. And we landed recently a version of the sample app in Kotlin just to get us started. Like have a look and let us know what you think. So just a quick word about like how Litho is being used at Facebook. To wrap up, we're using Litho heavily across the Facebook app on Android, Messenger. Some of the main like most prominent screens are like being converted or have already been converted. Workplace, Facebook Lite is fully based on Litho, and it's kind of tricky to talk about like performance like improvements because this is very context specific. So you can't like say in general you're gonna use and it's gonna be a giant win. In our experience, it has been, we got to a point where if you convert your product to Litho, you're very likely to get pretty big wins from traditional Android to Litho. And we are being very aggressive in our conversion because we're seeing a lot of benefits. And the cool thing is seeing that whenever you improve performance in a big way, you do get more engagement and stuff. So it's kind of, we talk about like how performance is a feature in products and stuff. And we see that when we run experiments in production and see like the big wins translating to more time spent in the app, more interactions and so on. So we're getting a lot of that. We work on performance as a proxy to engagement anyway. So yeah. And to wrap up, like the big thing with Litho, and like just be super like direct about this, like it's very easy. A lot of the stuff that we ship like from Facebook, very easy to kind of get the idea that it's like, oh my god, like why are these guys doing this? Like this is too complicated and stuff like this. But I think the cool thing with Litho and like trying to solve big problems at scale is that in this case, I think we managed to come up with something that feels very simple. Yes, it's doing a lot of fancy stuff, but you don't need like the performance wins necessary to adopt Litho. If you're into functional programming, I mean, a lot of the benefits that Litho brings you is very similar to the reasons you're like a lot of people are adopting RxJava these days, is because it's functional, it's declarative, it's composable, and we're applying a lot of these concepts, but for UI development. So if you're into writing functional code for UI, like Litho is going to be a big deal for you. The kind of code that you write in Litho makes it very easy to scale your problem. So I mean, suddenly you don't have to care about view types. You don't have to care about like messing with adapters anymore. You don't have to spend a ton of time optimizing layouts anymore because a lot of that stuff is taken care for you. So a big part of Litho is offering you a very simple way of writing UIs, but at the same time opening up a lot of possibilities of improving performance in a big way. And another cool thing here is at Facebook, we rarely like release something as open source before we proved it internally. So by the time we open sourced Litho, we had pretty like strong evidence that this is working really well for very complex products. So so this is something we're using like every day by a lot of people. So this is battle tested. So at the same time, this is battle tested for our use cases. So if you're bringing like new use cases, it's gonna make Litho better. Like please like say hi to us. I wanna hear more about this. And so if you go to appbuildlitho.com, you're gonna find source code, tutorials, API docs, sample code, and so on. So and that's all I had for today. Thank you.